Hey guys, so I'm going to give you an example of how to solve conservation of energy problems. Every problem that you do with conservation of energy is a little different depending on what type of energy is um, in the situation. So these 5 steps for solving these types of problems are really helpful because it walks you through what to do. So the first step is to draw the picture. So you'd read the problem, then draw the picture, mark the initial and final positions of the object. So if we do this project or this problem together, you have a 4 kilogram ball rolling down a hill that is 5 meters tall. So if I were to draw the picture, here's my hill, here's my ball, and then the ball's going to roll down the hill. So the initial position of the ball is up at the top of the hill. So I'm going to put a little I there. We use a subscript I to represent initial position. And then its final position is going to be down at the bottom of the hill. So I'll put a little F there. So then the next step is to decide what type of energy your object has at the initial and the final positions. So at the initial position, it's got height, it's not moving yet, it's at the top of the hill. So all the energy is in the form of GPE. And then it starts moving, it goes down the hill. Once it's at the bottom of the hill, there's no more height left. So all the GPE has become KE. Okay, so then if you go back to your steps, it says, so we did step 1 and 2. Step 3 is to set the initial and the final energies equal. Substitute in the equations and then plug in the known values and solve. So if we go back here, I'm going to set the 2 energy types equal. I'm going to substitute in my equations. So GPE, the equation is mgh. KE, the equation is 1/2 mv squared. So notice what happens with mass. If you have 2 variables that are the same on both sides of the equation, they cancel out. So that's why, well, they do give you the mass of the ball, but you don't actually need it because it cancels out anyway. So in some of the problems you'll see mass isn't given, and that's because it cancels out. So then you plug in your variables that you know. G is 9.8. Height is 5 meters. And that's equal to 1/2 v squared. And then from there, you would solve for v. I don't have a calculator in front of me, but I think you guys at this point know how to do that. So you would multiply 9.8 times 5, divide by 1/2, and then square root it. And that would be your answer in meters per second.